Hello friends, welcome to CodeChef. I am Suraj and in this video we will discuss this problem Tinder dating. So in this problem we will have a string with M and F as a character. Here M represents male and F represents female, and we need to form a contiguous group such that the number of male must be equal to number of female, and the only condition while forming group which we need to consider here is we cannot overlap the group selections. It means that one member cannot be in more than one group, and at least and everyone must be in at least one group. So first thing is here, this is a valid group selection. Then and if I'll select group like this is invalid because here F is in two groups, which is not allowed. And third possibility here is, let's say this. So let's say this is one group and this is one group. This is also not allowed because here in this F is not in any group. So these things are not allowed. And we need to finally what we need to do is we need to create groups in which total number of females and total number of males are equal, and we need to output the maximum number of groups which we can form. Okay, so let's consider the first test case here. In the first test case we have MF, MF, MF. So this is the first group, second group, and third group. So here the number of males and females in all the three groups are same, and these groups are not overlapping, and every members are selected. So here this is one of the valid selection, and it is also satisfying this condition. So here the maximum number of groups which we are able to form is equals to 3. So the output is 3. Now in the second test case, we can select the starting 4, then we can select these two, then we can select these two. Here again, in the first one, the number of males and number of females are equal to 2 each. And in the second group, number of males and number of female are equal to 1, same in the third group. So here again, we are able to form 3 groups. So, and this is the maximum number of groups which we can have with all these conditions satisfying, and number of males equal to number of females. So we'll output 3. Now here are the constraints which we can consider. Here is first of all, n is even, so we'll have the total number of males plus total number of female will be always be even. So, and the second thing is the number of males and number of female will be equal. So what does it mean? It means that we will have at least one group. How? Let's consider this situation. We have F, F, then M, M, M. So here in this situation, the only group which we can form here is this one. Okay, this is the only valid selection, and the number of males and number of females is equal, and hence if we'll select the entire string, then that will be the only answer possible in this kind of a situation. Here you might think that we can select these two as a group because number of males and females are equal. But if you'll do this, then we won't be able to select this two FF here and this two MM here, and hence it will violate this condition. So we cannot make selection like this. We must select everyone. Everyone must be present in at least one group, and the number of males must be equal to number of females. Now let's discuss the approach. So let me write the first test case here. We have M, F, M, F, M, and F. So let's start from the first index. Let's start from here. Okay. So now we have one male, and in order to form a group, we need one more female. Okay. And as soon as we go on the next position, we got one female. So here we can form one group. And in order to maximize the count, so we need to maximize the count. So it is obvious that we can only do this if we minimize the group size. Okay, this is possible when we minimize the group size. And here, as soon as we reach the set condition like number of male equal to number of female. So we can consider here that this is the minimum size of group which we can form, which is equals to 2. So here we can form one group. Then we will go to another M on the next position, and here again we need one female to form a group. And as soon as we go on the next position, we'll get that one female. So we can form one more group here. So we have, this is the second group, this is the first group. Okay, and then we'll go to another M, and again here we need one female. As soon as we go, we'll get one female, and hence this is the third group which we can form. Now let's discuss the same on the second test case. So here we have M, then F, M, F, M. Okay, so let's say we are on this position. So in order to form a group, we need one female. And now let's go to the second position. So now we have in total 2 male. So we required 2 females to form the group. Okay, so we have 2 male, okay, and 0 female. So we need 2 more female in order to form a group. Okay, so now we can go to this position. So we got one female. Okay, so here we got one female, and now we need one more female. You cannot form a group like this. If you form a group like this, then you cannot select this M in any group. So you cannot form a group like this. You must wait for one more female. Okay, so now as soon as we go to the next position, we got one more female. So now the total number of female is equals to 2. So number of females and number of males are equal, and this is also a contiguous. So here we can form one group. This is the first group. Again we can repeat the same procedure. So again, let's say we are on M and S. So here we have one male, and we need one female here. And as soon as we go on the next position, we got one female. So we have one male, we have one female, number of male and female are equal, so we can form one more group here. So this is the second group. Now let's say we are on F. Okay, so now we have one F and 0 male. So we need one male to form a group. So as soon as we go on the second position, we got one male, so we can form one group here. So in total, in this condition, in the second test case, we have 3 groups. And in order to form a group, we will make sure as soon as we satisfy this condition, we'll form a group at that position and reset the value of male and female to 0. So now let's discuss the solution approach. So what we will do, let's consider this situation, MF, MF, and MF. So what we will do, we will maintain 2 variables. First is RF. RF is the required female, okay, and then G is the gender of that person on that particular index. So let's say currently we are on this position, okay. So here G is equals to M. It means the gender of that person is equals to male. Okay, so what we will do, first we will initialize RF to 0, and then we have our variable here, group count. Initially this will be also equal to 0, so I will write in short form here, group count, it is also equal to 0. Okay, and what we will do now, as soon as we got a male, okay, we will increment RF, that is required female, okay, and as soon as we get a female, we will decrement required female. Okay, and when this condition comes true, that required female equal to 0, it means now we are in the balanced situation. We have number of males equal to number of female. It means at that position we can form one more group, so we'll increment group count by 1. Okay, now let's dry run this algorithm here and see if we are getting the correct result. So let's M, F, M, F, M, and F. Initially RF and group count is equals to 0. Okay, so now we are on M. So now the G is equals to M, so we'll increment RF by 1. So now RF will become equal to 1. Now we'll go to female. Here G is equals to female, so we'll decrement RF by 1. So now RF will again become equal to 0, and as soon as RF become again equal to 0, so this condition will become as will become true and will increment our group count by 1. So now our group count will become 1. It means that at this index we can form one group, which is this. Now we'll go to another index M. Here again we can increment RF by 1, that is required female by 1. Then as soon as we go to the second position, that RF required female will decrement, and again the RF will be equal to 0, so we will increment the group count to 1, so it will become 2. So we can form second group here, and similarly for third one we can form here. Now let's take another example and see if it works there also. So we have, let's say, F female first, then we have male, then let's say we have again one male and one female, and let's say we have female and male again. Okay, so currently we are on this position, and let's say we have required female to 0 and group count is also equal to 0. So as soon as we get a female, we will decrement required female by 1. So now this will become equal to -1. And now on the next position we got one male, so we'll increment RF by 1. So now this -1 will again come back to 0, and as soon as it will come back to 0, here this condition will be true and we'll increment the group count by 1. So now our group count will become equal to 1. So it means that we have formed one group here. Okay, now again we got one male, so RF required female will be incremented to 1. Then we got one female, so RF will be decremented to again 0. So as it is again 0, so we'll increment our group count by 1, so now it will become 2. And similarly here we can see that we can form total 3 groups. So here in this condition also the output is 3, and here also the output is 3. I hope this logic is clear to you. Now let's implement the same in code. So here first I am accepting t, the total number of test cases. Then I'm calling solution function total t times, and let's implement our solution here. So first we need to input the size of a string, and the next one is the sequence of all the genders. So let's do it n times, and every time we need a gender, so we'll input g, and we need to maintain two variables. First is the count, which will be initially equal to 0, and second one is required female, let's say RF equal to 0. Okay, and now here if g is equal male, it means here we need to increment our RF, and if g is equal female, if g is f, then we'll decrement our RF, and if RF is equal 0, then in this condition we'll increment our count by 1. Okay, and at the end our answer will be stored in count variable, so we will print our answer. So now let's run this code for these test cases. So we got 3 3 as an output, and this is correct. So now let's submit it and see if it's passing all the test cases. So our solution is accepted in C++. Now let's see the same implementation in Python. So here also I am accepting t, the total number of test cases, then I'm calling solution function t times, and for every test case first we are receiving n, the size of our string, and then we are initializing required female and count to 0, and then we are accepting all the sequence of character, all the sequence of genders in this variable a. Here a is an array of, a is a string, and then we are looping from I equal to 0 till n, and every time we are storing the current gender in g, and then we are checking if g is equal female, then we'll decrement required female by 1, and if g is equal to male, then we'll increment required female by +1, and if the required female is equal 0, it means now we are in the balanced situation, so we can form one more group. So we'll increment our count to +1, and at the end we'll have our answer in this count variable, so we'll print this. So now let's run. So here we got the correct answer. Now let's submit it. So our solution is accepted in Python. So I hope you got the solution in both C++ and Python and you understood the logic behind it. So let's meet in another video. Thank you.